In this question, we're looking at a situation where there are two cars traveling at different rates, and we want to find out one of the motion equations that allows them to intersect. This is a common type of problem that you'll see, and it demonstrates several different mathematical properties or processes. All right, the problem reads, a blue car pulls away from a red stoplight just after it turns green with a constant acceleration of 0.6 meters per second squared. A green car arrives at the position of the stoplight 4 seconds after the light has turned green. What is the slowest constant speed that the green car can maintain and still catch up to the blue car? So let's look visually at what this means. If we consider the blue car, it will be starting from position 0, which is the traffic light, and speeding up at a regular pace. The green car is going at a constant velocity, but will not cross 0 position until it is at 4 seconds, but going at a constant slope, which is the velocity. So what we want to know is what value of the slope will allow the green car, this diagonal line, to intersect the parabola and what the minimum condition for that to occur is. Okay, let's look at what we know in the problem. We know the initial position of each car when we set up the equation is 0, because that's when it is at the traffic light. We know the blue car starts with an initial velocity of 0. The green car has an acceleration of 0 because it is a constant velocity. And we know the blue car has an acceleration of 0.6 meters per second squared, and that the green car passes the intersection 4 seconds after the blue car passes through the intersection. Okay, let's write out some equations. So, for the blue car, B stands for blue. Let me write out the equation first. Now let me substitute in my values. Initial position is 0. Initial velocity is 0. Acceleration is 0.6. Simplifying this. Now for the green car, we start with the same formula. Initial velocity, initial position is 0. We don't know what the velocity is, but it's not 0. Now, the time is shifted by 4 seconds from the blue car. So I represent that as t minus delta t. So t minus 4 seconds because it was 4 seconds later into the intersection. And then this will be 0. Same thing with that t. So let me rewrite it. Like this. Okay. What I want to do is I want to set these equal to each other. Because I want to solve for when they are the same position at the same time. So I get 0.3 t squared equals vi t minus delta t. Next I'm going to simplify and solve for v. So I'll move the t minus delta t over here. And to find the minimum of the velocity, which is what we're looking for in this question, let me just move this up so we can see the velocity. To find the minimum of the velocity, what I'm going to do is take the derivative of the velocity and set that first derivative equal to 0. So let me rewrite this like this first. So that I'm setting it up so I can use the product rule. So I'm going to do dv dt equals and if you remember, the product rule for differentiation is the derivative of the first times the second plus the first times the derivative of the second is the derivative of for a two-term system. All right, let me just move that out of the way. So I'm going to need a little bit of space over here. Following through, we get all right. Simplifying along. T minus delta t times 0.6 times t minus 2 and 6 t squared over 4 t minus delta t squared, because that's to the negative 2. Okay, now we're going to set that derivative equal to 0. And to simplify that, 0 is the same as 0 divided by 1. So I'm going to cross multiply. Let me write this out. 4 t minus delta t squared equals 1 times all of this, which will just be all of that, okay? Just rewrite this one more time. Now let me simplify that. So 4 times 6, 6 times 4 is 24. With the decimal point there, it's 2.4. T minus delta t times t minus 2 times 6 is 12, and the decimal is 1.2 t squared. Now I'm going to divide both terms by t. Now I'm going to multiply this through. Oh, I forgot to distribute. No, this should work out. All right, 1.2t. And then 2.4 minus 1.2 is 1.2 times t minus 2.4 delta t. Move this over here so it's positive. 2.4 divided by 1.2 is 2. So all of that reduces to 2 delta t equals t. Now, in our particular problem, way back, remember, delta t is actually equal to 4 seconds. Which means 2 times 4 is equal to 8, which is equal to the time for our problem. And if we go back to the velocity formula, which was v equals 0.3 t squared divided by t minus delta t, if t is equal to 8, and delta t is equal to 4, this reduces to 4.8 meters per second, which is the minimum speed at which the green car must travel in order to catch up to the blue car. Thanks for listening.